Hello, everyone. Let's go ahead and see how we did. We'll take up a few of the questions. If we get them all, great. If not, that's okay. All right. So we're looking at some of these practice questions, and the main formula we're going to be using is this P is equal to A times 1 plus I to the power of negative N. So what we'll do is we will go ahead and put some blanks for each of these, and then we'll see how we did. Okay, so first one here, it's 4,000 is needed in 5,000 is needed in 4 years, invested at 6% compounded annually. So our p-value is going to be question mark because we need 5,000 in the future. Our I value is going to be 0.06, and our n value, the number of years, is going to be 4. And so P will be equal to 5,000 multiplied by 1 plus 0.06 to the power of negative 4. Now, we don't need to uh, multiply or divide our I values because since it's annually, that means once. Okay? And so 5,000 multiplied by 1 plus 0.06 to the power of negative 4. That's going to be $3,960.47 after rounding. I'm just making my calculator a little bit bigger on the display. Okay, $2,000 needed in 2 years. So let's go ahead and highlight that. At 4% per year, compounded semi-annually. Okay, so we don't know how much we need right now, but in the future we need $2,000. The interest rate is 4%, so it'll be 0.04. And the number of years that we're talking about is 2. So since that's semi-annual, we will take our I value and divide it by 2, take our N value and multiply it by 2. 2 times 2 is going to be 4. And so P will be equal to our A value, 2,000, times 1 plus I, which is going to be this 0.04, divided by 2 to the power of negative 4. And so on our calculator here, 2,000 times 1 plus 0.04 divided by 2 to the power of negative 4. And that's going to give us $1,847.69. Since there's a 0 in the end, that means we will round down. And so it is. Okay? And we can see it matches up with the answer we got from below. Letter C here, we have $10,000 needed in 5 years at 8% per year, compounded quarterly. Okay, so that's going to be, we don't know how much we need right now, but in the future we need 10,000. The I value is going to be 0.08, and the number of years is going to be 5. And now since it's quarterly, our I value will be divided by 4, and our N value will be multiplied by 4. So 5 times 4 is going to give us 20. And so capital P will be equal to 10,000 times 1 plus 0.08 divided by 4 to the power of negative 20. And so on our calculator here, we type in our 10,000 multiplied by 1 plus 0.08 divided by 4 to the power of negative 20. And so we're going to get here the $6,729. Okay. I just like to double check to make sure that this lines up. It does. So we know that we did this correctly. Okay. At the birth of their child, how much should a couple invest to have $28 on the child's 18th birthday? If interest is paid at 8% per year, compounded quarterly, and afterwards it wants to know how much interest is earned. So note that interest earned will be equal to just A minus P, whatever those happen to be. And importantly, we're talking about the birth of a child. Okay? So since we're going to the 18th birthday, that means we're talking about 18 years. All right. So how much do they need right now? We don't know. In the future, they're going to need $20,000. Our I value is going to be 0.08, and our N value is going to be 18. So 0.08, since it's going to be quarterly, we will divide by 4, and our N value will be multiplied by 4. And so 18 multiplied by 4 is going to give us 72. And so in our formula here, we're going to have capital P is equal to 20,000 multiplied by 1 plus 0.08 divided by 4 to the power of negative 72. And so if we take our 20,000 multiplied by 1 plus 20,000 multiplied by 1 plus 0.08 divided by 4, close the bracket, to the power of 72 of the negative variety. And so here, this particular couple is going to need about $4,800. So this P is going to be equal to, and notice that afterwards we've got a 4, so we will round down. So this is $4,806, which lines up with what we got. And now for the interest then, if this $4,800 is what they have at the end of their term, we can figure out the difference. So the interest earned will be equal to that $20,000 minus sign the $4,806.37. And so on our calculator, if we do this, 20,000 minus sign $4,806.37, we're going to get this $15,193.63. Okay, so not so bad. And keep in mind, at any point, all of these questions could ask how much interest is earned, but all it is to calculate the interest then is just A minus P. Okay. Lastly, but not leastly, we have an investment fund pays 6.3% per year, compounded monthly. How much should a 25-year-old woman invest to have 50,000 by age 35? So I guess my question to all of you then is, how many years are we talking about here? So, as noted, but for the benefit of the recording, if we take our 35 minus 25, that's going to give us 10 years. And so the woman in this case, she's going to invest over a period of 10 years. Okay. She doesn't know how much she needs right now. In the future, she wants 50,000. The amount of interest is going to be 0.063 because again, if you were to take 6.3 divided by 100, that's going to give us 0.063. And the number of years we're talking about is 10. Now, since it's compounded monthly, we're going to take our I value and divide it by 12, and take our N value and multiply it by 12. 10 times 12 is going to be 120. So P is going to be equal to A times 1 plus I. Oh, sorry. P is going to be equal to their A value, which is going to be 50,000, multiplied by 1 plus I, which is going to be 0.063, divided by 12 to the power of negative 120. And so on our calculator here, if we take our 50,000 multiplied by 1 plus 0.063 divided by 12 to the power of 120 of the negative variety, we get this 26,600 number. And so this will be equal to $26,673.51. We see on the end that there's a 1. 1 is going to be 4 or less, so we will round down. Now, before we can always check our answer as well. So how do we do this? Well, if we use our main formula, A is equal to P times 1 plus I to the power of regular n, we should be able to check to make sure that this equals 50,000. And so A would be equal to, in this case, this $26,673.51 multiplied by 1 plus 0.063 divided by 12. And we will put this to the power of positive 120. And our answer should be it should be just below 50,000 because we had to round down, right? So if we take our $26,673.51 and multiply it by 1 plus 0.063 divided by 12 to the power of 120, we get an answer that's pretty much bang on, $49,999.99. And we can see that there's a 7 on the end, so we round up. So this does equal 50,000, confirming our answer. Okay, and so with that, that's how we go ahead and analyze present value.